Dear students, in today's video we'll discuss about how to solve minimization problem using graphical method. Okay, we had discussed how we are solving maximization problem using graphical method. So here in today's session we will discuss about the minimization problem, solution of minimization problem using graphical method. Okay, it is just simple as that of how you are solving the maximization problem. Only thing is you have to be very careful with the signs. While you are taking the feasible solution, you need to consider the signs of the constraints. Okay, now solve the following LPP using graphical method. So you have the objective function minimize z equal to 6x1 plus 3x2 subjected to two constraints, that is 2x1 plus 4x2 greater than or equal to 16 and 4x1 plus 3x2 greater than or equal to 24, where x1 and x2 is greater than 0. Okay, so now what you need to do is, whenever you are doing a graphical solution like graphical method, first thing is you have to equate it. You have to consider this as an equation and put 0 for each and find the value of the other. That is, in the first constraint, if you are taking 2x1 plus 4x2 equal to 16 should be considered, then you have to put the value of x1 is 0, then get the value of x2. Similarly, when you put x2 equal to 0, find the value of x1. So you have to plot the points accordingly. Now we will solve this. Okay, now consider the first constraint. Our first constraint is 2x1 plus 4x2 greater than or equal to 16. I am putting that 16. So when x1 is equal to 0, what will be x2? x2 will be 16 divided by 4, that is equal to 4. Okay, so x1 is equal to 0 plus x2 is equal to 16 divided by 4, you get as 4. So similarly, when you put x2 is equal to 0 in this particular equation, you will get x1 is equal to, so here you are substituting as 0, you will get 2x1 is equal to 16. So 16 divided by 2, you will get it as 8. So you can put it in a table like this. That is, when x1 and x2, when x1 is equal to 0, x2 will be 4, and when x2 is equal to 0, x1 will be 8. So you have 2 points, 0, 4 and 8, 0. Now we can plot it in the graph, these 2 points. Okay, so I have the graph. Either you can take a graph paper and do it. If you are taking a graph paper, it will be well and good, because in graph paper you will get the points in much accurate manner. Okay, but if it is a plain paper, then you have to be very careful with the scale. So here I have taken 1 unit is equal to 1 centimeter. So while you are plotting, you have to be very precise, otherwise you will get a wrong answer. Okay, so it is better you take a graph paper. For the time being, I am taking a plain paper. So while you are plotting, you have to be careful, that's all. So here the first point is 0 and 4. Okay, so 0, 4, x1 is equal to, this is x1 and this is x2. So 0, 4 be the point, 0, 4. Okay, that is x1 0 and x2 is equal to 4. So this is 0, 4. This is the point. Okay, this is our first point. Then the second point is 8, 0. That is x1 is equal to 8. x1 is 8 and x2 is equal to 0. So this is our second point. That is 0, 8. Sorry, 8, 0. 8, 0. 8, 0. This is our point. So now I am plotting this. I am drawing a line. So here you need to draw the line. This shows our first constraint. This is our first constraint. Okay, so I have plotted my 2 points, that is 0, 4 and 8, 0, and this line shows the first constraint. Now we will go with the second constraint. What is our second constraint? The second constraint is 4x1 plus 3x2 greater than or equal to 24. I will write it as 24, equal to 24. So when x1 is equal to 0, then what will be x2? When x1 is equal to 0, x2 will be 24 divided by 3, that is equal to 8. Similarly, when x2 is equal to 0, I am substituting x2 equal to 0 in this equation. So x1 will be 24 by 4, that is equal to 6. So now I have 2 points. What are my 2 points? Here I have x1 and x2. So when x1 is equal to 0, x2 will be what? 8. and when x2 is equal to 0, x1 will be 6. So these are my 2 points. Now I'll plot these 2 points in the graph. That is 0, 8. x1 is equal to 0 and 8. So this is a point. This is 0, 8. And the next point is 6, 0. 6, 0. That is, this is the point. 6, 0. Okay, so I have 2 points. Now I'll join these two in order to get my second constraint. Okay, now I'm joining these 2 points to get my second constraint. Alright. So see, I have 2 constraints, I have 2 lines here. Now, look at the question. What is given in the question? That is 2x1 plus 4x2 greater than or equal to 16. It is told that 2x1 plus 4x2 is greater than or equal to 16. That means this is our first constraint. It shows that the feasible solution should be greater than this line. Okay, so it has to come in this part. That is, it has to come in this particular part. Then, what is the second constraint talking about? 4x1 plus 3x2 greater than or equal to 24. This is our second constraint. So, this is also telling that it has to come in this particular part. So, that means, which is common to both? This part is common to both, isn't it? First constraint says that it has to be above this first line. Second constraint is telling it has to be above the second line. So, which is common to both these lines? That is something like this. So, if to be very precise, the feasible region will be like this. Then again, you have this one. That means the feasible region will be like this. Okay, it will be above these 2 lines. So, it will not be here. It will not be in between these lines. It will be in this point. Okay, so you can mark the points A, B and C. Okay, it will be above A, B, C. Now, what is our objective? So, to be very precise, I can show you a better graph. This can be a better graph. So, you can understand it clearly. A, B and C. This is our feasible region. This particular, that means all the points above A, B, C will be there in the feasible region. Okay. So, now what is our target? We have to find out the coordinates of A, B and C. Here I have found the coordinates of A, B and C. See, if it is in a graph paper, you can directly get it. Here already A's coordinate is known, that is 0, 8. And C's coordinate is also known, that is 8, 0. But B we don't know. We will have to plot it. Just drop it down and see at what point it is coming. This is coming at 4.8 for x1 and 1.6 for x2. Okay, so the coordinate of B is 4.8, 1.6. Okay, so this is the total graph of this minimization problem. Now, answer is not complete. The problem is not over. So, what you need to do is, you need to find an optimal solution. That means, what is our objective function? See, our objective function is minimize z equal to 6x1 plus 3x2. So, we need to find the minimum value of z in this particular problem. So, how you will find the minimum value of z? So, we have these points. So, we need to find the minimum value of z. So, this coordinates is also known to us. So, again, you will have to find out what is the value of z. Okay, I am just writing it down here. Z for A. So, we have 3 points here. A, B and C. So, Z for A, you can substitute that point. That is, here for A, x1 is 0 and x2 is 8. Okay, so substitute that particular thing in the objective function. The objective function is 6x1 plus 3x2. See, Z, the objective function is 6x1 plus 3x2. So, we are substituting this x1 and x2 values for that point A. For point A, it will be 6 into 0, why 0? Because x1 value is 0 and x2 value is 8 plus 3 into 8. You will get it as 24. Then Z value for B. So, what is B? 4.8 and 1.6, right? So, the value of B is, coordinate for B is 4.8 and 1.6. So, you can substitute 6 into 4.8 plus 3 into 1.6, you will get 33.6. Then value for C, ZZ is equal to 6 into, what is the coordinate of C? 6 into 8 plus then 3 into 0. So finally 6 into 8 you will get 48. Now our objective function is to minimize Z. So you need to find the minimum value of Z. So according to this, the minimum value of Z is this one for A. So you can tell that optimum value of Z is at point A. So Z of A is equal to 24. Here x1 is equal to 0, comma x2 is equal to 8. Okay, so this is your optimum solution. So I hope this is clear to you. There is nothing. You will have to plot the points and draw the graph. And if it is a minimization function, the thing is you have to find the minimum value of Z for each and every point. If it was a maximization problem, definitely you will have to find the maximum value of each. So the only thing that you have to be careful is while you are finding the feasible solution, check for these particular signs. If it is greater than or equal to, definitely it will go above the line. If it is less than or equal to, it will go below the line. Okay, so that is it. So hope you have understood this particular problem. Thank you, students.